Hello and welcome to Path to Power, P2P. In this video, we will talk about how to use Safety to perform location-specific individual risk. This is one of the key important outcomes from PHAST Safety, where we will quantify the risk at the specific locations. One of its application in operating company is to identify the risky zone for the H2S release. So similar to a normal fast consequence model, assuming you have completed all the models, isolatable sections have been identified, whether environmental conditions been identified under parameters, the level of thresholds and the hazard intensity thresholds, minimum, maximum for the toxic parameters, flammable parameters, explosion, fireballs, BLEV, jet fires, pool fire is identified, and materials, you have defined the component of interest, and in the map you have included and uploaded the plot plan of the operating facilities. Under FAST Safety, we have a new tab, additional tab, and in this tab, we will identify key important things. We have ignition, population, and risk ranking points. Vulnerabilities, it is already fixed in FAST consequence model. It talks about people vulnerability indoors and outdoors. And this is what we will identify as well. So starting from the ignitions, I need to identify the potential ignition sources on this plot plan to empower Safety engine to calculate the location-specific individual risk. So what I will do under ignition, I will insert an ignition point, or it could be a polygon. We will understand the key difference between this and that. I will go to ignition point, and on this plot plan, I will identify ignition point here, for instance. So this ignition point has been added, and graphically it is presented as red dot. Going to the ignition point, I will identify two important things: ignition probability and the operation probability. Ignition probability, it is probability anyway, from 0 to 1 or 0 to 100. This one is a fraction. So based on the occupancy factor and the probability of that ignition, and also it depends on the source of that ignition and the type of that ignition. If we talk about exhaust from a gas turbine generator, so the ignition probability is 100%. If we talk about fired heater, it is 100%. If we talk about vehicles, traffic load on that road, so it is not 100%. Vehicles, they come and go. From that perspective, I can define 0.7. An operating probability. If it is continuous operation across the whole day, I can claim 1. So now the ignition spec for that point has been identified. I can also go to the ignitions. We have another type, which is polygon. And in this polygon, I will define potential location where ignition could take place. And this is how it is presented. Going to the ignition polygon also, I will do the same thing. Ignition probability, operating probability, this is 1, and it is completed. So by completing this, I have all potential ignition that will impact and will influence my leak scenario from the models, and based on the liquid and gas release dispersion, and also based on the wind direction, it will determine the risk accordingly. For the population, I will do the same thing, population polygon. So I have, this is area where I have high intensity of people, they exist. This is how it looks like. Category is so important. Is it admin, public, vulnerable public, process control operator? So they are operators. You need to identify density, how many personnel per meter square, and the population. In this number, I can claim 10, and the density, it is, I would say, 0.5 per meter square. Help, when you go to help, it will explain what does it mean by population and density. So this is an explanation about density population. So I have now completed population. Vulnerabilities, I have indoor and outdoor. If it is outdoor, flash fire vulnerability, it is 100%, and toxic vulnerability, it is 100%. I will keep it that way. If I have indoor, flash fire, definitely it won't be like that. It could be 0.5. And toxic vulnerability, I will give the same percentage. Risk ranking point, I will add, this is risk point, another risk point, another risk point. And here you can, by the way, give a specific name, rename. So now this is completed. Once it is completed, you need to go to the scenario. So this scenario is so important. This is where we define specific scenarios. So from here, I have all scenarios. To simplify, I will delete this scenario. I have only a propane storage day, and this is the model, the isolatable section I have built. Day weather, I have day weather category, and day population set, ignition, day ignition set. This is the name of the folder I have created under risk. If you have another isolatable section, you can create a new scenario and you will add it from here. So these scenarios are really, really important. So this is my scenario. I need to double click on that scenario and I will run this scenario. So the entire isolatable section alongside my weather specification, parameters specification, and all risk categories I have defined here, considering the ignition, population, vulnerabilities, and risk ranking points, the model will run to achieve the scenario. And once the scenario is completed, we can go to the risk and risk detailed, and from that, we can see the all potential outcomes we can generate. So now it is completed. See, now this risk is clear. I need to see the multiple level, and this is so important. If you have a specific criteria for the public individual, it varies from 10-4 to 10-3. You can add any one of those here. So these are the selected item. I will continue next and then finish. So based on the isolatable section, the model has determined the risk. This actually assuming if you have imaginary person, this person will die, considering these frequencies around the isolatable section. This is how we can read the location specific. I will go again to home ribbon, and from that one, I need to see the multi-vulnerability. Multi-vulnerability, definitely it will include the indoor and outdoor to tell you the number of fatality, whether these personnel indoor or outdoor. So this is the blue one is the outdoor vulnerability. It talks about this is the area where you will have an imaginary death of one person at any time, considering the 12 months in a year, and the brown one it takes into consideration the indoor vulnerability. So with this location specific, there is no problem. With this one, there is a problem. With this one, there is no problem. Considering this presence of ignition source, this ignition source is far from this one. And also considering the population intensity in this area, it is far from these contours. So there are so many things. In risk also, we have the FN curve, the frequency versus the number of fatality, and it is great one. So this is the maximum criteria line, and this is the minimum criteria line. If you have different criteria, simply you can go to the result, and from the result, this is the maximum criteria, minimum criteria, and this is the predicted frequency. You can take all these categories, 3 categories, on an Excel sheet, and in the Excel sheet you can define your minimum and maximum based on your company guideline. In brief, and before concluding this video, here detailed risk is not available. How to make it active and to get access to the detailed risk? When you go to setting, and from the setting you have risk preference. Risk preference, go to the level of detail in risk, choose full details of outcome and contribution, and then click OK. Once you modify these settings, going back to home, okay, we need to rerun one more time. Once the run is completed, risk detailed will be active, and you can access to the relevant outcomes underneath risk detailed, and you can utilize and leverage from these outcomes. Now it is active, and from it you can have the exceedance, and this is, you see, individual risk as a graph. So this is considering day and night from the weather perspective, and propane day and night. This is the scenario I have created. I would like to include the catastrophic rupture for the pipeline, and also small leak, medium leak, and large leak as a standalone risk assessment. These are the potential scenarios for that pipeline. So this is the overpressure exceedance. Very important from the personnel protection and mitigation measures and building mitigation measures. And this is the dynamic pressure in terms of overpressure with respect to the frequencies, and this is the impulses curve as well. These curve and these charts are so important, and it provides a great input when you perform fear analysis, fire explosion risk assessment, to understand the consequences of the gas dispersion and the consequent explosion, and what kind of mitigation measures you need to apply in place. Mitigation measures, it will be reflected on additional scenarios as a sensitivity case to run and to see your proposed mitigation measures and its impact on minimizing the location specific individual risk. Thank you for your listening, and see you soon in other videos. Until then, stay safe.